Greetings to our respected instructor, Forester Hannah G. Pantaleon, to our teachers, and to my classmates, good day. I am Christian Engalan, and together with my group mates, we welcome you to our subject, Geology and Forest Soils. For today's discussion is all about the characteristics and importance of forest soils. So forest soils are made up of mineral deposits, are generally well-drained, and come in a variety of different types. Moreover, forest soils are often acidic, organic, and low in chemical fertility. The texture and variety of the soil are affected by where it is generated. It may be shallow, deep, sandy, clayey, wet, arid, frigid, or warm. The general characteristics of forest soils are generated by the different aspects of the forest. Under natural conditions, forest soils have developed over a long period of time under the influence of forest vegetation. Primarily, they evolved through natural succession as coupled components soil and vegetation of the specific forest ecosystems. Therefore, forest soils have a lot of influence when it comes to the properties of forests, such as forest vegetation and the occurrence of natural succession. There are also soils now covered with forest vegetation, often plantations, on land that were not naturally forested. Forest vegetation has profound influence on the genesis of forest soils through their canopy, biomass, litters, and roots. Forest soils in turn influence the dynamics of forest vegetation. In addition, soils are probably undergoing processes that give them forest soil-like characteristics. Example, litter layers from trees, woody organic residues from deep roots, and associated soil microbe and fauna populations. Like other soils, forest soils have developed and are developing from geological parent materials in various topographic positions interacting with climates and organisms. So forest soils retain many of their natural properties even long after clearing for cropping. To conclude, the characteristics of forest soils are generally influenced by forest vegetation and natural succession, which means that the specific forest areas produce various types of forest soil from different aspects of the forest. That ends my discussion. I hope I've explained it well. For the continuation, we have Ms. Criziel Mae for the limitation of forest soils discussion.
Best day everyone, I am Criziel Mae, your reporter for the limitations of forest soil. Forest soils have some physical and chemical limitations in agricultural standard that help them retain their vegetation and soils in the natural state. Physical limitation. Soils can be stony. Right? Stony soils are described as dry because water drains through them quickly. So, dali ra madrain ang tubig sa stony nga soil. This poses a problem to gardeners and landscapers in creating gardens. Next is gravel. Type of soil that drains too quickly, leaving your flowers and vegetables struggling to find water to become healthy. So, parehas ra siya sa stony. It is also a problem for the gardeners. It's because dali ra man drain ang water, so ma-dehydrate ang plants and vegetables or flowers. Next is sandy. They have low capacity to hold water or nutrients and bind other particles. They are loose when wet, very loose when dry. So, grabe ang sandy. Dali ragid po na siya makadrain of water to stop them on supporting a plant and becoming healthy. Next is clay. They have electrical charges, both negative and positive, that allows to have high water and nutrient holding capacity, and they participate. So, ang clay is reddish na siya nga soil, then moisturized or basa-basa nga siya nga soil. Next is the extreme moisture. Oh. First is arid, are also known as dry soil. This soil lacks humus and moisture which restricts the infiltration of water through the soil. So na gihapon siya kulang siya moisture or water. So mo na siya himong hadlang sa mga roots to absorb water. No, muna siya. Next is waterlogged. So this waterlogged is kabaliktaran na siya sa arid. Due to excess of water in soil, the plant roots fail to respire, making them weak and sometimes die. So masubrahan po water ang soil mo na ang plants mamatay ihapon. So ang arid is kulang, ang waterlogged is sobra og water. Next is the chemical limitation. First is the acidity. So acidity, it decreases the availability of plant nutrients and increase the availability of toxic elements. Acid meaning sour ang lupa. So makamatay gihapon na siya plants. Gihapon na siya maka-healthy, no? Next is alkalinity. Alkaline may cause soil alkalinity or it reduces the nutrients available to plants. It might stunted growth and nutrient deficiencies. So, di gihapon siya maayo nga soil para sa plant. No? Kay makuhaan man ang nutrients na available para ana nga plant. So, actually this involves salt, no? Next is salinity. It is the amount of dissolved salts in the soil solution. It produces toxic to plants, and as the concentration increases, the plant is poisoned and dies. So di gihapon ni siya maayo, no? Ang salinity. It dissolves it dissolves salts in the soil. So ang salts is dili maayo nga para sa plants, no? Munang ma-poison and mamatay. Next is sodicity, a process that involves salts in which it increase runoff and poor water storage, surface crusting, poor emergence of crops, problems with cultivation and erosion. Sodicity. Alright, para sa akong gayong na, it also involves salts in which poor sa water storage, surface crusting. So dili maayo gihapon ni siya sa plants na magka-problema ta sa crops and sa cultivation. So di gihapon na siya maayo ang sodicity. Next is acid sulfate conditions. The soil is always wet, usually entirely saturated, and sometimes they can be greenish. So murag naaga na siya lumot-lumot kanang murag grabe ka moisture pud nga soil, naglumot-lumot dam dili na siya pwede sa plants. This reduces the crop growth or leads to death of vegetation. So dili gihapon siya maayo. So that's all. That is all. That is my topic, and that is the limitations of forest soil. Thank you.
Permanent vegetation. Forest soils develop under the influence of permanent or semi-permanent vegetations. The occupancy of a land for so long a period by a particular vegetation exerts some effects on it. The vegetation adds organic matter and its decay products into the soil, removes water and nutrients for a long period, and adds organic matter and harbors soil organisms that have trimmed by 002 dose, modifying effects on soil fertility and productivity. Undisturbed forests have thick, dense canopy covers, the thickness of which may exceed many meters. These layers acts as an umbrella that intercepts solar radiation and regulates evapotranspiration and heat transmission. As a result, a microclimate develops in the ground of forest which is entirely different from adjacent non-forest areas. Deep and extensive roots draw water and nutrients from a larger soil volume. They leave lateral and vertical channels that act as drainage and aeration routes. Forest soils have more roots, deeper roots, and large roots. Therefore, forest soils have deep and well-differentiated soil profile.
Hello everyone, I am Emarie PANIZALES from BSF2B, and my topic is all about the natural succession in the forest floor. So both soil and vegetation have a life history, going through stages of birth, growth, and maturity in the same way that they do on a bare rock or wetland. So the series of development is called natural succession. Natural succession on a bare rock is called lettucer, and in a wetland is called hydrocer. So let us see what happens in lettucer. So we all know plants cannot grow on a bare, hard rock. However, bacteria can thrive inside the cracks and obtain nutrients from the substances dissolved from rock. So, as there is a succession of plants such as bacteria, lichens, mosses, herbs, shrubs, pioneer trees, mature forest, and ultimately climax forest, there is also a series of soil horizon. So, on the surface of many forest soils, a thick horizon develops by the accumulation of forest litters. For wide variation in lithology and climate, we see the development of different types of forests and associated soils by AVILA 2008. So, hydrocer is a primary succession which develops in aquatic environments and result in the conversion of a water body into a land community, say a forest. So, a hydrocer is a plant succession which occurs in an area of fresh water such as in lakes and kettle lakes. So, in time, an area of open fresh water will naturally dry out, ultimately becoming woodland. So, during this change, a range of different land types such as swamp and marsh will succeed each other. So next is the forest floor. So the forest floor is a unique and spectacular feature of the forest soil, particularly temperate. So the forest floor usually contains a thick layer of organic residues accumulated by the fall of litters or dead parts of a forest vegetation, including leaves, branches, twigs, flowers, fruits, barks, and even large rocks. So, a plenty of mushroom and fungi proliferate on these damp litters. So as soon as the litters fall on the soil surface, they are attacked by soil organisms and start decomposition. So the remaining part gradually accumulates on the forest floor.
Hi, this is Mera-Andribec AVILA. In continuation to our topic, we will discuss to you the 5 importance of forest soil. Forest and forest soils play a broad, complex, and interactive role within the environment. Soils have provided the foundation for trees and entire forests over millions of years. Soil is an important component of forests and woodland ecosystems as it helps regulate important ecosystem processes such as nutrient uptake, decomposition, and water availability. Soils provide trees with anchorage, water, and nutrients. In turn, Trees as well as other plants and vegetation are an important factor in the creation of new soil as leaves and other vegetation rot and decompose. Forest soils and their interactions carry out key functions that contribute to food security and healthy environment. So the first importance of forest soil is the climate change. What forest and forest soils do? So carbon emissions are a major contributor to climate change. The world's forests, in one of their many rules, act as a significant carbon store. 650 billion tons of carbon, or nearly one-third of the total in terrestrial ecosystems, are captured in forest. Forest soils also store a quantity of carbon equaling that of the global forest biomass, about 45% each. An additional 10% of carbon is found in forest dead wood and litter. In total, forests store as much carbon as the atmosphere. Number 2. Ridge, hill, and mountain slopes are stabilized by tree roots, which supply the soil with the essential mechanical structural support to prevent shallow landmass motions. Soil erosion can be controlled or reduced using sound forest management methods, such as measures to introduce or maintain forest cover on erosion-prone soils. Soil conservation necessitates forest regeneration in dryland zones. So, the planet needs sustainably managed forest just to control soil erosion and for us to conserve soil. It says here that the tree roots stabilize the ridge, hill, and mountain slopes, and then it provides soil with necessary mechanical structural support to prevent shallow movements of landmass. Like for example, the landslides that is rarely occur in areas with high forest cover. Then number 3 is major ecosystem benefits of forest and soils. So, forests are also a key component of watershed management. An integrated approach of using natural resources is a geographical area drained by watercourse. Watershed management is a very sound way to protect and rehabilitate areas prone to soil degradation and erosion in upland areas. It also forest and soil characteristics are among the key parameters assessed in watershed management planning. So in number 3, the benefit we get is that it reduces soil erosion, risk from landslides. It provides and maintains the planet's supplies of clean water. Then it ensures the balance of water cycle. So in watershed management also, they are more integrated in natural resources. So it is a very sound way for them to protect and rehabilitate areas prone to soil degradation and erosion, especially to upland areas.
My name is Jeanroo BUSTAMANTE and I'm here to discuss the remaining 2 importance of forest soils. Fourth is soil conservation in semi-arid and arid areas. Start with forests and trees. Forests act as protectors of soil resources to prevent soil erosions, like preventing and reducing salinization. Salinization refers to the increase in salt concentration in an environmental medium, notably soil, and is harmful because it reduces growth and stops plant reproduction. Arid zone forests have the challenge of optimizing the trade-offs between water yield and soil protection. Fifth is forests can reduce mountain soil sensitivity to degradation. Steep slopes and thin soil mountain ecosystems extremely vulnerable to the erosion. Mountain soils are often degraded and invariably do not provide enough nutrients for plants to grow well. It is estimated that around 45% of the world's mountain area is not or only marginally suitable for agriculture. The degradation of mountain soil and vegetation cover may happen gradually or rapidly, but often takes many years to repair. In some cases, it is irreversible. In order to protect our soils, we need to protect our trees and forests. The importance of these effects has often been ignored in the past, with the clearance of tree vegetation leading to the loss of millions of hectares unproductive land.